Good evening.
Evening, sir.
Hi, how are you doing?
Good, sir.
Awful.
Good, good.
I'm doing awful.
What happened to you?
I don't know.
Hmm?
I don't know.
I can tell you. It's Friday. You need to go on the road, and the teacher guy have you in class. That's the reason.
I actually like going to class.
Hmm?
I like going to class.
You like going to the park?
No, I like going to class.
Okay, so what's the problem then? Oh, maybe you just need a slice of cheesecake.
Nah, I want to not be alive for a few.
Stop it.
Okay.
Stop it. Stop it.
Sir, good evening.
Hey, Papi. Hold on.
Sir, you didn't post it last class. I was checking for it because I missed it. I was out of town. I was checking for it and I didn't see it.
Okay, let me see if I can try it for you. No, okay. Let me check to see if I have the device. Okay. I have the other device. Moya sent me something to see how I can do it from the iPad, but that don't work. All right, so I have the device here with me, but it needs it needs charging. Let me just check. I should have a charging device. Okay, yep. I have the charging. I have the cable. Okay. So this is why when you take out something, you need to put it back exactly when you're finished with it. Because I'm finding the battery to charge, but I'm not finding the cable. Ah, man. 137, good. Moving in 10, 20 seconds. Let's see. That's number two. We're going on number three. I can find, okay, great. I found the charging device. I need a, come on, wait, I need a live. I can't believe it. Okay, so while that gets a little charge, I'll try and do that in another couple that is getting a little charge. I have work for you, you know. I have some work for you. All right, so while I was waiting for you, I got a little bored trying to. I didn't know if I should go on Amazon or I should really start the preparation for class. Or I mean, I'm prepared for class. I have what I want to do with it tonight. And then I just started writing foolishness on the screen, and I say, hey, and I started salting. So
Are you shopping for something?
I know, and that's why I get myself into trouble because I go on these things and I see things that I really don't want, but I think I want it, and then I go buy it, and then I put myself into trouble, right? So I didn't buy a thing. So what I want you to do. So while I was playing around, I started working. I started off writing foolishness, and then I converted it into a goodish questionish, and then there is an error somewhere, and uh, and I want you all to either work the question and then tell me where it is that I went wrong in the question. Thank you. I give you a couple of minutes.
Good evening.
Has anyone found the error?
Sir, just but this is differentiation, not integration.
I know.
Sir, would it be the second line?
What about the second line?
Yes,
Um,
sir.
I take it we're doing implicit differentiation.
Mm-hmm.
And I think I distinctly remember that says when we're doing this form of differentiation, each time we're differentiating y, we should put a dy up by dx. But
Mm-hmm.
in the second line, I'm seeing 42 in bracket y. Isn't that supposed to be 42 x dy by dx?
Okay. Um,
Sir,
go ahead. I just want to answer your chef. Go ahead.
okay. Sir, so I don't see that problem with it. What the problem I see with line two is when I recall that when we're doing this, 42xy would be considered as two terms,
Mm-hmm.
and therefore 42 it would be you'd be using the is it the what is it, the not power rule, the product rule, and therefore you would have 42x, which would be the first term multiplied by the differential of the second term, which is y, and then that would be dy by dx, um, and so on.
Is the second part is the second part okay with the plus y times one?
Um, no, I don't. Sir, I just started mega chat, but that's so far that's the thing I noticed that is off.
Sir, is
Okay.
it that the 7 was taken out of the equation completely?
Why was that taken also?
Sir, that's a good question. Would you like to answer?
It was
Not too far.
Sir,
no,
sir, the 7 would be
because
0 given its
yeah,
implicit
because
differentiation.
the
So that's
differential of
correct.
7, yeah, is
Okay. Is this about with the where wait, hold on.
The second line,
Is
right?
this
Yeah. I'm
is
sorry,
this
Nigeria.
where we had to like evaluate dy over dx at a certain point?
Yeah, but I didn't give you that part. I didn't give you that. I didn't give you that section. So yes, it's the same topic, but I didn't give you that section for you to evaluate it to the point.
Oh,
Yeah. Chevy, I'm gonna come back to you now. So say to me what it is that you were saying before.
Oh, sir, I just wanted to add with it, but the product rule differentiation, as rightfully said by Moya, should be included in the second line. But what I also observe is that it should be 42x, given that it's two terms being multiplied. So the second line should be presuming it's 42x, then so that's the first term multiplied by the differentiation of the second term, right? Which would be just dy by dx or 1 dy by dx, right? Plus the second term, which is y, so that's correct. Um, multiplied by the differentiation of the first term, which would be just 42. So
Really?
yeah, yes, if it's 42x, then the differential of 42x would be just 42, given that we just dropped the x.
You're doing so well, and then you made an error. But I'm not going to tell you the error that you made, though. I want you guys to pick it up. But you can con. I want you and Maya to work the question now. Um, the pair of you are on point away from. Well, you got a little further than Maya did. But you made a little error somewhere. But both of you and Maya, go ahead and do the stuff. The question. I want the rest of you to attempt it, please, or tell me why it is that where the error is. I think I kind of like this. I think I kind of like this. I'm going to do more of this. I'm going to do some questions with some deliberate errors, and I'm
Sir,
going to
of
ask you
course,
to
I
find
like things about so move.
no, I just like I don't know why. I just came. Well, you joined late. I was just saying to them that I joined. I was the only one here, and
Mm-hmm.
I started doodling on the screen. Not even with my pen. I was using my finger, and I was like, oh, but it don't really come out too big. I could reduce it if the pen, start giving me problems. And then I started writing some foolishness, and then I said, hey, and then I decided that I was going to work the question, and then here's an error in one of the lines, and I say, no, I'm going to continue this stuff. I'm going to continue. I'm going to continue. And then I had a thought that, when they come to class, ask them to find the error. So I can tell you that there is an error, and I'm asking you to find it. So yes, Moya, you're seeing something. Chevy is seeing something as well. I want the rest to make an attempt. And then in how much time here? Because we need to continue our integration. So not gonna, yeah, give you a little time. I want you to work the question now, please and thanks.
sir.
Yes, please.
I think I'm done.
Good job. Chevy, who is this? Hello.
So, sir,
Yes, please.
yeah, so that's where the things went off with
All right.
line.
Step up in. So let me ask you now. Let me ask you because I asked you before I couldn't answer that part. So let me ask you now. Um, is this piece correct?
No, it's not correct, sir.
This piece is incorrect, right? That's what you're saying?
Right. Yes,
Oh,
sir.
what is supposed to be?
It's supposed to be y times 42, which is the differential of 42x.
So what you're supposed to get there?
So you should have in that line you should have 42x by multiplied by dy by dx
Mm-hmm.
plus y multiplied by 42 plus 3 dy by dx equals
So,
0.
so what do I have right here?
Um, oh, you do have 42y.
Aha. So that's the question I was asking and you couldn't answer me.
Sir,
No, I did something and this
oh,
is a
you
grown up.
group. It seems a group.
No, I don't. No, that's not. Don't group. It's not group. Tell me the correct term. I what?
Um, what you call it something? I don't remember what the terms.
Come on, man. Come on.
Uh,
Don't do this to me now. I would
there,
love if the others could come in to chime in on this one. Come on, Mario. Come on.
mm, 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 mm.
What do I have out here?
Sorry, I used the factor.
Very
Tell us,
good. I factorized.
Yeah,
Good. So I factor. What did I factorize, Mario?
42.
I factorize a 42. So therefore, I'm only
Mm-hmm.
differentiating x, y.
Right.
So let me go
So,
back to you now. Is this correct?
in that case, it is correct, sir. So
Okay.
the other point where I see the error again is where the end part. It shouldn't be the last line, sir. The answer. It shouldn't be 42y. It should be that's the denominator. It should be 42x plus 3.
Right. Very good. Very good. Very good. I think I like this. Honestly, I don't know why I've never done this before though. I don't know why I've never done
sure,
this
I got
before.
something. I got the same answer, but I think I worked it different.
You got
Not
to say, no, yeah. You'd have worked it different. You'd have worked it how Moya worked it. Moya worked it as 42x times y. I factored out the 42 and then use it as xy. So so the correct answer is the correct answer is
it will be minus 42y over 42x plus 3.
right minus 42y over 42x plus 3.
Okay, you have it.
Very good. So
Sir, so
yes, madam.
it's still at the first line, sir, you factorized, yes, but you ate the x, you didn't
I
include
know, I
the
know, I know the error is there. That's what I'm saying. I know the error is there. So
yes.
as I said before, I just start off and I just started doodling, and then I said, "What the hell?" And I said, "Okay, fine." And I started working, and then an
So
idea
that
came
is
to
it.
mind.
So the error was still in line 2.
I know. So the error is right here. It's supposed to be X.
Mm-hmm.
Yeah. And then I just carried all the way through, all the way through. So I'm not going to do the question because I'm expecting you at this stage, at this point in the calculus course, that you also be able to do the question and figure out where teacher went wrong. And I'm thinking that I may need to, I'm going to give you a coursework piece with something looking like this. And oh, I am going to make some, oh Lord, I love it.
Oh
Thank
my
you,
God.
Jesus. And I'm going to make some errors. And you all need to find those errors and tell me, right? And each error that is found will be given a mark.
Debugging in math. Wow.
I love it. I love it. You know, I saw something. I was a
So
little.
why you choose to get creative for this group, sir?
I have no
Sir,
clue.
please
Maybe
don't
because it's
do
one.
that.
No, I'm sorry, Dijon. Is it
Sir
because
would
it came to
add
my
to
class?
my
Everything left
depression.
you.
Is it because it came to my class feeling very oozy on a Friday evening? I'm gonna blame it on
Sir,
you.
wait for your
Sir,
next
I
quarter.
didn't
You get
Nope,
feel woozy.
innovative, sir.
nope, 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 nope.
Sir, sir,
I'm
I
gonna tell you
believe
with the
that
class.
given the state of the island, we can't afford any experiments at this moment in
Yes,
time.
sir, sir, I
And that's
was,
fine.
Now
And that's
is
fine.
not the time to be innovative, Mr.
No, but
Shan.
no, but I'm telling you, the Prime
sir,
Minister says he's going to build a smart city. So you'll be able to fix all the kinks into by St. Elizabeth, Manchester, Westmoreland, and then places of mashed down. So I'm giving you the platform to undo Unicam, totally, you know, because I will go with you. So you know it was built and there were kinks, and you now need to fix those kinks. So I'm mimicking it. So fix the king. So yesterday I came home and I was a little, what was I? I was a little tired, but I left campus about midday, all knowing that I had a 3 o'clock, 3:30 meeting. So I came home hurriedly, came home, got me something to eat, and then I said that I was gonna see if I can get even a little 1 hour sleep. And I was there searching on social media and saw a video of a student in one of those prominent all girls high school. And you know, she was just joking around in school, and then she went back now to 2025. And 2025, good girl is a math teacher. And I was like, wow, this is really nice. And I'm saying to you, students, some of you, most of you, I believe, are working. One of these days, we can talk and we can share ideas, but we don't know where the future holds for us. We may find ourselves in a situation where we get into the training department where we have to be training people. And it's like, but I never know I had this teaching something inside of me. So we need to be able to understand fully what it is that we are doing. It may be your son, it may be your daughter, it may be your nephew or your niece. Somebody may come to you to say, I need help. You need to be in a position to debug something. Just like how you guys are excellent at debugging those viruses and kinks in computers. Yeah, man. So that's very good though. All right. So tonight, I I am I'm gonna be moving into a little bit more of the integration. I think the good thing about it, I have done one of the applications of differentiation already. Sorry, yeah, one of the applications of differentiation already. Because I was looking back and I was saying to myself, oh Lord and Father, I am behind, I'm behind. And I said, brother, just relax yourself. You've done tell the students already, so you're going to meet them in the Christmas. So we're killing off yourself. Just relax. That was a part of what happened to me yesterday is that I had some anxiety. But don't worry about it. We did use up some of the time to find out how people's state of mind was and so forth and so on. So it is perfectly plausible. What I'm going to be doing, we've already done live. Did I do error under the curve with you? Remember I was in error under the curve with you? Anybody remember that? Was it this class? Yes, man, it was last week Wednesday. It was last week Friday, actually. When I was doing the error under the curve, I remember I was coloring something and then something was right with something and I fixed it the following class, one day this week. Anybody remember?
Think so, sir.
But
and I used Desmos and I colored something in purple and then I saw an error, but I wanted to show you the upper limit minus the lower limit.
yes,
Anybody?
sir. Yes,
Right.
sir. Remember, sir.
So guess what happened? It means then that I've covered the areas under applications of differentiation and integration. Because the application of differentiation would be stationary point, and applications of integration would be um, integration using the definite and indefinite approaches. So I am not too far off in completing, but yes, I know I want to give you some more. So it's not too bad. I'm not in a bad state now that I look at it because I actually was thinking, hey, I like that. All right. So you had a question, somebody? Chevy, you were saying something, or Alex? So which one of you? All right. So this is business. Yeah, no, this is plus one. All right. So I did so integration. All right. So I have done. I forget that I was reading the syllabus a little in a little haphazard manner. So I did all right. So what I'm gonna do is tonight I want to I want to I want to give you what time is it? 5:42. 5:42. All right. Let me go through. Let me go to this. I type something for you. Let me just see if I can screenshot it and send it off to you to make my life a little easier. When I was my teacher never did them something for me. You, you sink or you swim. You sink or you swim. All right, I'm gonna give you a few. Oh, come on, don't do this now. I'm gonna give you a few minutes. No, I'm not gonna give you no minutes. I'm gonna work through this with you. Um, so we talked about integration of exponential functions. Integration of exponential functions. I am expecting questions on this. Um, mainly on the multiple choice. They may, they could be troublesome and give you something like this on the essay card, but nonetheless, let's go. So we are looking at the integral of the exponential function. So how would I know that we're talking about the integral of the exponential function? I thank you for asking. The elongated S is the integration sign. The elongated S is the integration sign. E is the exponential function. Whatever this is, that will be the power. And it means that it's going to be a power in x because I'm differentiating rubbishness. I'm integrating with respect to x. So let's go again. The elongated s tells me that I'm integrating E is telling me that I'm integrating an exponential function. The function is in x. It means therefore that I'm going to be integrating with respect to x. So the integral of e to the ax is just a function really. It's going to be 1 over a. It's 1 over a times the ln e. See the e here? Once it is like this, no, hold on. Before you ask a question, it's a pattern that I want you to see. I want you to pick up the pattern. I want you to pick up the pattern. So just work with me the pattern first before you ask me the question. I want you to
It's
pick up the
not a
pattern first.
question,
Okay,
sir.
go ahead. Go
I
ahead.
dropped off and so I'm lost. My laptop battery died, so I don't know where
No,
we're
don't worry
at
about it.
now.
I'm just starting. I'm just starting, love. I'm just starting. So let me go again. So we're talking about the integral of the exponential function. Integral, and there are two types. The integral of the exponential function. All right? How do you know that we're integrating? Look at the elongated s. The elongated s is telling me that's the integration sign. Okay, is anybody seeing my screen?
Sir, it's blurred.
I'm seeing it screen.
Seeing it now,
You need
just
the whiteboard.
Chevy, you seeing it now? I don't know why
Maybe
I'm not seeing it.
connection is still down.
Experience to load. Leave quickly and come back, Chevy. I'll wait on you. Leave quickly and come back, please.
What? 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 Yeah, I have to play. No. Oh.
Maybe it's this internet thing because it's taking so long to come back.
Sir, you're in and out too.
So I'm also in and out.
Yeah, you're kind of in and out, sir. But it could be my side too.
Yeah, that's what I'm wondering. Anybody else having me coming in and out?
Just as it relates to your volume.
Oh my, I'm not having that issue.
I don't know because I am full bar. Have you seen the screen now? Okay, cool. Are you also hearing me?
Yes, sir.
Okay. All right. So let's go again. So we are looking at the integration of the exponential functions. There are two types. And how do you know that we're talking about the integration of the exponential function? In one sense, you are seeing the elongated s. The elongated s, which is the sign for integration, the elongated s, which is the sign of for integration. And when you look at that, you're also seeing the e, which is the exponential function. You're also seeing the e, which is the exponential function. All of that is raised to a power in x. Therefore, we're integrating with respect to x. Now, just look at what is happening. When we are integrating the exponential function, we will always find ln e. We'll always find ln e right there. So it's going to be 1 over a. Lord have mercy. Sir, where we get a from? You see ax up here? I'm differentiating the power. When I differentiate the power, I have the power to be ax. When I differentiate the power, I am going to have, I'm going to have it as a. So it's going to be 1 over a ln e. ln e. So why ln e? Because it's the exponential function that we're talking about there. So it's 1 over the differential of the power ln e. And then remember, I did say to you the differential of the exponential, the integration of the exponential function is the let's go. The differential of the exponential function is the exponential function itself. Also, the integral of the exponential function is also the exponential function itself plus this piece here. So you notice I'm going to write that my e a to the x, my e a to the x, and then I plus c because of course it's an indefinite integral. Of course, because it's an indefinite integral. All right, so let's go again. So the differential of the exponential function is the exponential function itself. When we are integrating the exponential function, we are also going to be having the integral of the exponential function itself. So whatever the differential function is, the integral of the function is going to be the same. So watch me. We are integrating e to the ax. I am going to be differentiating the power. The differential of a to the x is a. Then I'm going to reciprocate it. I'm going to have 1 over a ln e. Why, sir? Because there's an e right there. So 1 over a ln e, and then I'm going to put back all of the function right here. See it right here? Put back all the function there. Plus my c. Right? But watch me now. When I'm simplifying it, I'm just going to have just 1 over a e to the ax. Why? Because ln e is equals to 1. Remember, ln e is equals to 1.
I have a problem with your font choice, sir, because the 1 over ln 1 L, sir.
Well, that's all. I can't change it. That's how the software writes it. That's how the math software that I use writes it. So I can't change it. If you notice, it's this there. It looks like this. IN.
Listen, catch it.
Yeah, man. So that's what it is. So just let's go again. So when we're integrating the exponential function, you are going to be differentiating the power, then you reciprocate it, then you're going to have ln e, the exponential function itself plus c if it is an indefinite integral. Remember that ln e is equals to 1. Ln e is equals to 1. So what you're going to now have is just 1 over a times the exponential function plus c. Okay, So I have a little note, some notes right here. Let us see if it makes sense. It says we need to differentiate the function and then reciprocating it times the given exponential function plus c. Does that make sense?
I'm not following 100%.
You're not following, but are you not following? So you're going to differentiate the given function, and then you're going to reciprocate it. And when you reciprocate it, you're going to times it now by the given exponential function, and then you're going to add c to it. Talk to me, right? Talk to me now, talk to me, talk to me now.
Go.
Hello there. Merry Christmas, how you been?
If I were you, I would stick to the calculus one. I think you may make a little bit more money, especially you have some 10,000 bills to pay.
Sir,
Yes, please.
you can't let it go now.
No, not until I finish calculus one. No, negative, never.
Yes, sir. So,
Listen, something to me, but stop. Talk to me.
yes, sir. But just, I don't know. I don't get this that we're doing so far. I
Okay.
don't. Yeah.
All right. Okay. One more time. All of you just listen up. One more time. We are integrating the exponential function. All right. We're integrating the exponential function. The integral of e to the ax dx. The integral of e ax dx. You're integrating the exponential function. You see the elongated s. You know that you're talking about integration. You see e. You know that you're talking about the exponential function. When I'm integrating the exponential function, it is when I am going to first differentiate. I'm first going to differentiate the power. That's the first step. Differentiate the power. When I differentiate the power, then I'm going to reciprocate it. I'm going to reciprocate it. 1 over it times ln e times ln e as a reciprocal. And then we are going to multiply all of that by the exponential function itself. You remember when we're doing differentiation? In order doing
Yes,
differentiation,
sir.
we had the exponential function itself. So the same thing for integration. So you're going to write back the whole function itself and then plus c. Plus c because we have an indefinite integral.
Right.
Now, hear what I'm saying.
Sure.
When you're given the exponential function, ln e is equals to 1. So technically what you're going to have is just 1 over the differential of the power times the exponential function itself plus c. Am I clear?
Yes, sir. So,
Okay,
and in
great.
all cases, ln e will equal to 1. Right?
And if you don't believe me, put it on the calculators now. Evaluate all of your
I
ln e.
believe you.
Yeah, man. Trust me. ln e is
Sir,
always
what
1.
I don't get right though is the x. I see that we differentiate because the function is e raised to ax, right? That's
Right.
the function.
Mm-hmm.
And we say we
Mm-hmm.
differentiate the functions which will get the
A.
yeah. What
Mm-hmm.
happened? Oh, is it because the
No.
differential of
Hold on.
x
No.
is 0?
No. Excuse me?
No, it's not. It's not 0. A number raised to the power. No, never mind. I forgot to say. But yeah, what happened to the x? That's what I'm trying to understand.
Moya, you got to be joking.
Oh, is it dx?
When you differentiate ax, Moya, with respect to x, what do you get?
sir. I'm not-
Moya,
Oh,
differentiate 2x on it, please.
okay. I see
Differentiate
it.
2x.
I see it. I
No,
see
no, no,
it,
no, no,
sir.
no, nothing.
No,
I don't
I
want, no,
honestly see it. Let me
no,
tell you,
no,
sir.
no, 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 no. Differentiate 2x for me. Differentiate 2x for me. I can
It's
material.
two. It's
Good.
two. I
Differentiate
just
AX.
realized, because E
You're,
is
you're
raised to AX,
Friday,
sir. That's why I'm saying I
you're
wasn't looking at it as
Friday jerk chicken and chicken foot soup will not taste good.
sir, must see it. No, must see it.
Oh my
I was
God.
looking at AX as the power itself, like the entire power, not as A being um
The numeral.
the coefficient of X.
Yes, yes, I. All right.
Yeah.
Are there any questions? I said usually gone, but are there any questions? All right. Remember, if you are not understanding and you leave the session, trust me, it not gonna make it any easier for you.
Finish my 200.
All right. So now we need now to look at the other version of it. Version one is where you have the integrated sign and you have the integration sign with the exponential function. You have the e. Now let us look at option two. Option two is where we're integrating, but there is no e. We have a. We have no e. We just have a. No e. We just have a. Watch me. In this case, I didn't use AX because I didn't want to confuse this A with that A up here. So I just use up here as BX, right? Really and truly is saying something. I didn't want to put A there because I wanted to be able to differentiate the A. So watch me. If you recognize it is the same thing, we are differentiating the power. The differential of BX is B. And then I'm going to have ln A. It's just like what I have it up here, ln E. And then I'm going to write the function AB to the X, similar to what I wrote up here, plus C. In this case, we know that ln E is 1. In this case, ln A is not going to be 1 because we don't know what A is. It could be ln2, it could be ln3, it could be ln5. So what is happening is this one and this one are exactly the same, except that one you're given the exponential e, and the other one you're given to give a to the bx. So both are the same. Both are the same. The only difference is ln e is equal to 1, but ln a is not equal to 1. It's equal to another number other than 1. So therefore, you have to keep the ln a as opposed to the other one where you don't have to keep the ln e. But sir, what if I wrote the ln e in my answer? Would I be incorrect? No, you wouldn't be. But guess what?
Yeah.
What may happen is what may happen is if it's a multiple choice, you may not see LNE rather in it. You may just see the 1 over A, e to the A to the X plus C. And that's what it is. So just take a few minutes. I'm going to give you 5 minutes to just look at it. And then we're going to be doing some questions. And those questions will help to concretize what it is that we're doing. So I give you what? I give you 5 minutes to just look at it. All right. So you have an example. The integral of e to the 2x dx. Can you just tell me what the answer is supposed to be, please? The integral of e to the 2x dx.
So it's going to be 1/2,
1/2. Any, sir?
2. 1/2 e, and then the original e to x, something. E raised to 2x.
Incomplete.
Plus c.
Thank you, please.
Yeah.
Was that difficult?
It wasn't. It's not yet difficult.
Please don't follow Nigel. You say Nigel quiet, nobody wake him up. Let him stay. Come, what's the answer for this one? Come now, what's the answer?
It's 1/2x plus 5 raised to all of that, the original equation, and then plus
Plus
c.
2.
Was that difficult? Was that difficult?
Getting one.
Okay, all right. And only because I said something very mean, so it's sounding like your Ninja's sister,
How is that?
courtesy of Maya. Come to that.
Oh my gosh. Sir. All right.
So is that plus C or a plus E that?
Plus what?
Is that a plus E or a plus C?
Plus C, man. Hey,
Oh man.
sure. Leave me alone. It's because you asked that question, we're gonna put a nice one
Oh
on the board just for you.
no. No, don't do
So
that.
what you tell us to be quiet for your side class then?
Maya, see, I told you to make him sleep, and you go wake him up. Yeah? I tell you to
I
make him
mean,
sleep.
sir, are you actually
No,
waking me? Not kind you
no.
reference him. I never say nothing for,
You
for
go,
wake him.
you go wake up Nigel.
You
Come.
just wanted it.
All right, quick and fast.
Yeah, no, it has to do the quotient.
And you're correct.
Quotient,
So
yeah.
let us go ahead and apply the quotient rule and then you reciprocate it. So quick and fast for me. So this is a good exercise for refreshing your quotient rule.
Sure. So it's going to be what? Mhm. It is going to be 1/, yeah, don't feel like that makes sense. But 1/-2/x+1 squared, and then raise, or you're gonna have back the original equation plus c.
Well, the last part correct, but let me find out from the class. Is her
Yes, sir, but don't have, I think she have a -2. Maya is a 2 you have for your numerator.
yeah more where she get the
Yeah,
negative from?
yeah, want figure
Yeah,
out
one.
how, so.
I don't know where she get the negative from. Anybody else get a negative? You know, last night I had a conversation with my calculus, business calculus students, pre-calculus students. Teacher, that just dawned on me. They're the only courses I taught this semester. Pre-calculus, business calculus, and calculus one. I'm calculus out. Anyhow, and try as I may, I was having a conversation with them and they wouldn't answer. Jeez, please. And they wouldn't answer. And I say, the dangers of continuing to teach this class at this point is that come next class when I say to you, do you remember what it is that we've done? I'm going to get a resounding no. You're not answering me, students. What is wrong? Answer me, man.
Sir, may I try to figure out where I went wrong according to you?
Actually, I look back on my answers.
Yeah. So, and that's a negative one because in the numerator, it's going to be the differential of the numerator. All right. The differential of the numerator. Sorry. The numerator times the differential of the
It's the denominator, ma'am.
denominator. Sir, at the right sum of but me I should have wrong thing. Yeah, the denominator times the differential of the numerator minus the numerator times the differential of the denominator, which is x plus 1 times 1. Oh, I see where I went wrong. All right, so don't listen to me. That was incorrect. I'll reevaluate my answer.
All right. So you see where you're not supposed to have a negative sign, no?
Yeah.
So what is it that you have? So tell me what you're supposed to have now.
Sir, I'm not sure if mine is right, but I have this look like some Japanese, but I have one over x minus x over x plus 1 squared.
Okay. Anybody agrees with him? Anybody agrees with Shiv?
So I'm not like I'm really never hear Manchester.
Run it again, Chevy.
Sir, as mentioned, I have 1 over x minus x over x plus 1 squared. Then you have your x minus 1 over x plus 1.
Anybody agrees with it?
So you asked if anybody agree with me. No, to be honest. I just
No, right. So it's right. So the question is not for you. Me ask if anybody else agrees with
okay.
him.
Okay.
Nigel, you agree with what he said?
Not that me have, sir. Not that I have, sir. So
Mario, go
but
ahead, please.
when I do it over, I'm not getting 2, I'm getting 0.
You're not getting what?
I'm getting 0 over x.
Also, the
1.
denominator, x plus 1, times the differentiation of the numerator. What's the differential of the numerator?
It's going to be 1.
Good. Minus the numerator. Minus the numerator. What's the numerator?
X minus 1.
Right? Put those in parentheses, please.
Yeah.
Good. Times the differentiation of the denominator. What's the differential of the denominator?
1.
Good. All over the denominator squares. X plus 1 all squared on. So now you're going to be, so x plus 1 times 1 is x plus 1, agreed?
Yes.
And negative times x minus 1 is going to be a negative x plus 1 down.
Pause. You say x times 1 is going to give you. Oh. Okay. I was not.
You're not distributing the negative sign over everything.
Yeah, and
I know that is a problem. You're not distributing the negative sign over the stuff.
I just went ahead and canceled out the x.
Right. So Chevy, I'm not in agreement with you, Chev.
Lord, I pray this kind of dilemma don't find me in my exam. Oh, I won't have an exam. Okay. answers.
Julie, you're not talking to teacher tonight. What is wrong? Mario, let me hear something from you. Alex, you're too silent. Your silence is deafening, Alex.
There, sir. There, man.
Yeah, man, but we want you to tell me one of the answer then.
Sir, Juliana is responding to you in the chat. She says she's still heading home. So that's
Oh,
why
JJ?
yeah, you're
Yeah,
not paying
but this is
attention to the chat.
no, I'm not seeing anything in the chat. Oh, I, um, what this is saying to my students is that you are forgetting how to differentiate your quotient. You're forgetting how to differentiate your quotient. That is not good. What's your final answer, Mario? You see, this is not the problem. You know? The problem is not the integral of the exponential function. You know? The problem is your differentiation, something that we've done moons ago, many moons ago. What's your final answer, Mario? And I need to hear the other answers before I move on. And I want to move on. Okay, the silence again is deafening.
Says four.
No.
Terminal me I do wrong. I do it over 1,000,000 times. But and it's obviously the part where so you can just do it because I really can't see where me I go wrong with this distribution thing.
Sir,
Because I do I
sir, no. Okay.
No, am I hearing right that you don't know how to do you don't know how to differentiate a quotient?
I know, but the part that is getting me is where because what I am getting the answer I'm getting when I do the calculation. It's so you're saying it's not correct. I'm trying to figure out where it is wrong. I genuinely can't. I'm trying. Don't see. I don't see how it is wrong because anyway I do it. Matter of fact, when I do it different ways, I'm getting different answers. So far, I've gotten three answers: -2, 0, and 4. I don't know what else is
Sir, my
wrong.
light went and it just came back. Okay.
I was wondering where you going. I don't even you know when you saying goodbye. You couldn't tell me say you like was gonna you should tell me say
Sorry.
you like was gonna go first and then you go.
Sir, I didn't know. I
You
didn't
should say
know.
sir, my light is gonna go now. So I soon come back.
Sir, I'll tell them to notify me first. Oh,
Please.
next time.
Absolutely. Next time. All right.
Yeah.
Let me let me see if we can save the class. Dejeuner. Let me see if we can save the class. I want you to differentiate x minus 1 over x plus 1 for me, please, Dejeuner. Quick and fast. Differentiate for me y equals x minus 1 over x plus 1 for me, please. Alex now talk. Chevy get something that is
Sir,
illegal. Yeah.
sir, me just reach home.
All right. Hurry up and see if you can do the thing for me now.
That's number 3, sir.
Yeah.
All right, sir.
So I give the final answer, or just the differential.
Yeah, whichever. Give me the differential. Let me see. Let me see what you have. No, why you laugh? Give me the
uh,
differential.
I have 2 over x plus 1 all square. So
Okay. So thank you, Nigel, for saving the class.
Sir, you never took the chat, no, sir.
Alex, I saw something in the chat, but I'm only now seeing the correct answer. What I saw in the chat was minus open bracket x plus 1
No,
or
believe me,
x.
sir.
Eh?
Just believe, man. But I was typing it, but I couldn't find the
Or you couldn't find something?
yeah,
Oh,
the
see,
key.
Mr. Tell me, man, look how long me call upon you, Alex, and hey, me not dealing with it tonight, man. Look how long you could have said, boy, sir, ropes.
Sir, give me 2 minutes.
Uh,
Now me I try to solve it.
All right, then hurry
so
up.
the thing about me at the distribution of the minus
Okay,
sign of the parentheses.
right, I saw that. Yeah, all right. Good job, though. Good job.
but man, I think I get the
No, man,
this.
no. So the differential is okay, no, Nigel. Go figure it out. Figure out how you can write the answer
All
in the
right,
nice,
sir.
English. Yeah, go ahead.
Sir. So, let me tell you why I get that. I hold on. So I got that because I was like typing out everything without enclosing them in parentheses. So I got 0 because of that. And now that I use the parentheses and using my proper calculator, I got the 2, the positive.
Praise the Lord. So you were the first one who was pretty close because you said -2 and everything else was right, but it's just that you have a negative sign. But we can't do incorrect answers. You have to get it right. All right. So 3 of you gone. JJ, you said 2 minutes. 2 minutes gone.
Hello,
Um,
sir.
who else is there? Chev, you need to go fix that, because me no know where you give me a while ago, Chev. No I lie you.
So the final answer
What's the final answer? Yeah, that's what I'm interested in.
Is
Nigeria. So,
1 over 2 over x plus 1 squared, then the original function plus c.
Okay.
Okay. Okay, that's all I get.
Mm-hmm. No, JJ, you're getting Moya's third answer, which is not correct.
All right, sir.
The denominator part is correct, but the numerator part.
So is the final integration answer you need now, sir?
Mm-hmm. What do you think it is? Moya gave me something,
I wonder if it's the other way around.
but this is incomplete.
It's
So that's why I
how,
just said okay.
sir,
So would it be 1 over 2x plus 1, sorry, 1 over 2 over 2x plus 1 squared and x minus 1 brackets.
I
You
didn't get.
said, sorry?
You said 1/2 x plus 1 all
No,
squared.
1 over, yeah, 1 over 2 over x plus 1 squared, bracket x minus 1, the original function plus c.
That's the same answer that
That's
Moya
the same
gave.
answer that I do?
Yeah, incomplete. Raheem, talk to me now. Nicole, talk to me now. Zidane, talk to me now. Mario, I need to hear from you. Christine.
sir, but I know why, yeah.
Sir, I seen something in the chat, sir.
Why is it incomplete? If I said the C that
I feel your pain, Moya.
they just look really difficult for the time problem.
All right. Somebody put something in the chat. Oh, okay. Osh. Osh, Papa, never mind.
Sir, I sent some to am I off again?
Yeah. All right. So, all right. No. So let me do the question.
Finally, sir, finally.
Yeah, I wasn't going to do it, but
Oh, my sister, yeah, pull it out, I will, sir, but
yeah, but I boast about my class so much that kind of put a dagger through my heart a while ago. I can't do one little something. So kind of vexed, but y is equal. So I'm going to let y equal x minus 1 over x plus 1. So therefore, dy by dx is going to be equal to the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Dy by dx is equals to 1 times x plus 1 is x plus 1. That's going to be minus x. I'm going to multiply two negatives together. I'm going to get a positive number over x plus 1 all squared. Come on.
Wait, sir, can I stop you?
Mhm.
All right, so you said time, oh, okay, sir.
That,
So
that is a place that is giving students a lot of problem, because guess what? This one times this negative one gives me a negative one, and negative one times x is a negative x, and negative one times a negative one is a positive one, and that's what is giving a lot of your problems, and that's why I'm upset. Not at this stage. You're not just learning differentiation. You learn it long time. Let's go. That cancels that. So I'm left with dy by dx is equals to 2 over x plus 1. All right. So now, so what students are saying to me that this is going to be 1 over 2 over x plus 1 upon all square.
is it that we're supposed to restrict that to?
But really, when you divide it by a fraction, you invert, don't you? So your final answer then should be x plus 1 all square over 2 e to the x minus 1.
Sir, I was going to ask if that was the answer. No, I was going to ask if that's what you're looking for. But
Yes,
I missed. I should have shoot my shot. Okay.
yes, ma'am.
That.
But at
Sir,
least you finally got the differentiation.
Nothing close to that answer, there, sir.
Say it again.
I was saying nothing close to that answer, sir.
No, that's not true. You got the 2 over. Didn't you say 1 and 2 over x plus 1 all square?
Yeah, but that's the differentiation, sir.
Yeah, but all you have to do now, Papa, I just put on the same
Invert,
something.
sir.
No, man. If once you get the differentiation right, Papa, there is no way you can get the question wrong, because all you're going to do is itch up the original things to it, that, and your plus c.
you know, sir, you know what when I was thinking about it, sir, I was thinking all the other examples that you gave, they were not fractions. And I
Mhm.
was thinking implicitly they are
over 1. So it would be like, no,
Ah,
yeah,
no, you're correct. You're
yeah,
correct.
over 1. So
So when you
that
flip
would
it now,
mean,
the one coming the numerator down.
right, exactly.
Yes,
And
yes.
then yeah, that was my thought process.
Mm,
And now because we have, a numerator and a denominator working, we can just flip it the
right,
same.
right. Why, Jesus, that were hard. For those of you who still don't see what is happening here, so I'm rationalizing. So I want to get rid of so I'm going to multiply right here by x plus 1 all squared. And if I do that, I also need to multiply the numerator by x plus 1 all squared. Because when I multiply the numerator by x plus 1 all squared and the denominator by x plus 1 all squared, it's as if I'm multiplying by 1. So I really am not disturbing the stuff, right? So it's as if I'm multiplying by 1. But look at what is going to happen. Look at what is going to happen. That cancels that. And then now, x plus 1 all squares times 1 is when you're given this x plus 1 all squares. And then the 2 alone in the denominator gives me this 2 right here. And that's how I get it.
Yes, sir. So you're not usually on campus.
Me? You
Mm-hmm. Tell me that me come look for you yesterday.
You were what?
I was looking for you yesterday.
Yesterday was which day? Tuesday? Thursday? Yeah,
Yesterday
man.
was
Yeah, man.
Thursday.
I was there. I left about midday.
Oh,
What time you got there?
around 3.
About 3 o'clock?
Mm-hmm.
No, man, you only see me now. At that time, 3 o'clock is difficult to get home. For my, you notice I'm generally early for my class.
Yeah.
I can't stay there I can't stay there beyond 3 o'clock really, or else I will never get home
Yeah.
to start my 5 o'clock. Trust me. Yes, it was Thursday. Yeah. All right. I spent a longer
Sir,
time. Go ahead, sir. Let's
yes,
cross the
sorry,
road.
sorry to cut you.
Go ahead.
Yeah, I stepped away. No, I got the over the x to be 2 over x plus 1 squared. So I got that. I see now you have for the answer x plus 1 squared over 2. So I'm
Right.
taking that you interpret the denominator to be the same as 2, right?
Mm, mm,
That's
mm, mm,
no.
mm, mm, mm. I'm reciprocating. So what I really have is 2 over x plus 1 all squares over 1. And when I flip it, I'm going to have 1 over all of that. So, when you went to look at school and you divide in two fractions, you invert and multiply.
Yes, when you divide the two fractions, you invert one
Yeah,
and multiply. Yeah, yeah,
right. Yeah,
I
I
remember
that we
that.
do. Yeah, that we do. That we do. So you need to go back and look at that, right? But guess what? I must move because I really never expected to spend so much time on this one. I really, 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 really never expected it, but I didn't want to tell you. If you know me very well and see the way I manage a class, I I don't just come and just do the work. I want you to be able to do a thing or two with me so that I can know what you're about.
Oh, I see it. I see what you did.
Okay. Big up yourself, my papa. All right, let's go. Let's go. On the mark, get set, go. Let's go. This one here is all right. Let me just give this. I don't want this was what? This was 3. What if I give you this one? E to the x squared minus 70x. Just tell me the differential, the integral for this one, please. Hmm.
1 over 2x and then e x squared minus 7x.
Everybody agrees?
So that plus C is always a part of your answer.
Because there is no upper limit and there is no lower limit. So it's indefinite.
Sir, 2 is from the square, right?
Yeah.
Okay.
I'm differentiating x squared minus 7. So I'm gonna get 2x. All right. Are there any questions? You see, it can just make sure so when I mark them papers there, you see all of them because silent ones them in the class will not contribute to nothing. I'm gonna try and make sure I pass the course. That may I tell you. Because I don't know what it is that you're doing. I call upon you.
Sir, take time with you, sir.
Not take time with you, man. Why if I pass the course? Why if you talk to me? You see, I can tell you about those who talk to me what they know from what they don't know because they're talking to me. All right, let's go. The integral of 2 5x dx. Now, please note, it's not e. Please note it's not. You notice all the questions that were done just now. You never even bother give me ln e in it because you know ln e is 1. And I didn't even bother ask you for it. I didn't ask you for it. What's your the message gonna talk?
Sir, so it's going to be it is going to be 1 over 5 open bracket ln 2 close bracket, and then you have the original equation and no, oh yeah, that's my Sir, yeah, hear me?
You know, see me write something to my mommy. Yeah, man, you're right.
Oh,
Sir, I get that one there, sir.
You don't get that.
No, sir, I get that
Okay,
one.
Maria, can you explain for me, please?
okay. So from the above here, where we have the rules, in the case where we don't get the exponential, but we get another variable or another number to work with, it is not going to be treated as e, where e will be equal to ln. It will be equal to 1. All right, let me start over. So you can scroll, go up to the original, the rules so that they can see it.
Oh, you not see my screen because I'm there a long time.
Oh, you're there. Okay. Yeah. So number 2, we're following with number 2. So we have a raised to bx. Well, from the first rule, a e is what would be there, which will, once we differentiate e, it's going to be ln e, and that will be equal to 1. In this case, we get a
let's say I don't know. Maybe I try, but
Let me another
it's not.
variable.
Yeah, I don't want to say variable because in the case down there, it's not a variable, it's a number. So
It's a
we
constant.
get right, all right, constant is a better term. So we got a constant. And now when we differentiating that, we're going to have one divided or divided by the differentiation of the power, and the power in this case is 5x. The differential of 5x is 5. And notice the b in the rule. It's from bx, and differential of bx is b. So then 5 will take that place
So
because
scroll back
5x.
down to the question, sir.
Oh, yeah. Or sir could let me copy it and put it up top so we
Sir,
don't have to back and forth.
sir, if I would care to try and summarize what Moya said. So
Yeah, try.
number 5, where we have the constant 2, which is raised to the
Mhm.
power of 5x, we're saying that we're putting 1 over the differential of the power. So differential of 5x is 5, right? In bracket, we put ln 2, which would be the constant given, right? Then we would essentially rewrite back the function plus c.
And the other critical thing to note is, remember, in all cases, ln e will equal to 1. But in this case, the constant ln a or 2, it will not equal to 1. So therefore, we have to evaluate it. We can't just drop it out. And remember now, if b, any number times 1 will give you back that number. But in this case, it's 2. We have to evaluate ln 2 to rather ln 5 to be able to ln 2 to be able to get our final answer. If we substitute in all the variables or the numbers for the variables. Sorry, I tried. I don't know how further.
Yeah, and that's fine.
But then she get me. She makes me up worse now because
Sure.
I put she put a good room a while ago, and then she's chipping
Oh
with the
my
5
God.
and the 2, and I said, Jaja, when we
It's
done
because the back and forth in that I don't have.
Nigel, she remind you of going to the country and say, how far is this place? And say, just go up on the
Sir,
road and turn.
sir, but it's
And you
true.
reach up on the road and can't find no
I
turn.
still a
No.
reach
Sir,
for
me feel Maya over explain it some time. Me
Man,
just
come on.
explain it. Me
Right.
just
I
explain it
understood. I
simple a while
understood what
ago
you were
and
saying.
then
Yeah, I understood what you were saying. And it is important. Let me tell you one of the things that I do to get me to this place. I I talk to myself a lot and I taught the math out because you have to learn the jargon. So I know she was struggling with constants and variable and whole number and them something there and then, Yeah, so you have to speak. You have to speak and speak the language so it is that you can be very comfortable. Because you see, what I find is that when I speak it and I'm
Yeah.
speaking it to myself in the exam, it is making a lot of sense. It is flowing. I know what my next line is going to be, and it is seamless. You see, all those exams that I did and I got A's for them, it is because I was able to talk it through and I know what is coming next, and I can just go and just work it out, just do the stuff. Those other ones that I struggle with is because either I wasn't practicing enough or I wasn't speaking the jargon enough. So what is the next step? But I have this, I have that. What is the next step? What am I supposed to find? I said, oh, this is it. So when the question's supposed to take me 5 minutes, it's taking me 15 minutes, right? Because they're not so fluent with it. And fluency will be part of the language, what it is that you're expected to do, support, and so on. Anyhow, very good. So what I'm saying to you, Nigel, is when you have the both integration of the integration of the exponential functions. One is where the base is the exponent is e, and the other one where the exponent is a constant. When the exponent is a constant, well, matter of fact, for both of them, you're going to use ln. So when the base, let me find it and show you. When the base is e, the exponent, we're finding ln e of it. Similar to when the base is a constant, we're finding ln of the base. The only difference with the ln e now is that ln e is 1. So once it is that you get the exponential function, e as the base, you don't have to write ln e there because we all know that ln e is 1. When you're given the base as a constant, you got to write it. All right? So you have to put the ln e. So both are actually saying the same thing. Both are saying the same thing, right? So
Yes,
it's going to be 1 over the differential times ln of the function. I mean, times ln of the base, times the function plus c. Once it is that you're talking about an indefinite integral. Sorry, you're coming in, Nigel.
so I get it. So it's understandable that because ln e is equal to 1 for the first example, you don't necessarily need to repeat
Got
that.
you.
So that's what I was trying to explain, you
No,
know.
man, and you did it. You did it. No follow them here. You did it.
Thanks,
You did it.
Maya.
You're welcome. You said thanks. Okay.
Yeah, I was just opening my
All right. So, hold on.
Yeah.
I JJ, come. I'm asking you to just tell me the answer for this one, and your classmates will tell if you're right or wrong. I want to make sure that they get it. I don't want that little traffic to go over that place. So, dear sir, take out all of the brain cells. Come.
What is that, sir? What is this, sir?
This is not bad.
All right. Let me see if I understand it based on what I want. So, sir, we're gonna have one. Oh no. Sir, there we about 1 over 2x squared.
Is it 2x squared? What are we supposed to do with that? We're supposed to?
Or differentiate, sir?
Yes, man. So differentiate it, please. Yes.
Oh, wait. Okay, let me get it. Let me see it. 4x. 4x minus 1.
Mm-hmm.
And then since it's a something there, a number, going to say what is that? Insert?
No, it's ln.
Oh, ln in 3.
No, not tell me about no in. Is that the Virgin Mary? No. ln. Or ln in.
Sorry, sir, sorry. It's because it look like in, sir.
Yeah, never mind. But it's ln. Go ahead. Correct so far. By the way, I don't know. Is she correct so far? Give her some motivation, no?
Yes, sir. Similar thing,
Yes,
sir.
sir.
Right, good.
Oh, sir, the ln means like logarithm of 2.
Yeah, it is right. It's a natural logarithm. So ln is a natural logarithm. Yes. So ln 3. Continue, Maya. I mean, JJ.
Right. So we're going to put back 3 2x squared.
No, tell me that, Tell me raised to.
Sir?
Tell me raised to.
Oh, sorry. 2x raised to the second power.
No, man. 3 raised to the
3 raised
squared.
to 2x
Right.
squared minus x plus 3 plus c.
Is she correct?
Yes, sir.
Good job.
Sir, I am waiting until you completely throw away what we've done so far and then dissect this question. I'm patiently
Which one?
waiting.
Which one you want
Sir,
to dissect?
sir, you normally have a tendency
Go away from
to.
here. You see, you, Maya, and Nigel, go away. All three of you, go away from here. Sure. I have to behave myself so nicely tonight.
Sir, you love roping people in your conversation there from
Straight
there
up.
feel.
Straight up. Right? I'm well behaving myself. And then, oh no, will come disturbance my peace. No man, trust me,
Just
Papa.
run the
It
next
is
question, sir. Oh, my
no, but it cannot done, I mean, there's nothing. He's expecting for me to give him something that is going to wow him, and there's no bottled water here to be wowed. It is what it is. All right. This is the final example because there's really nothing much to it. But I love the energy though. All right. Just quickly tell me that one. There's nothing fancy about these ones.
Fancy. So that's going to be 1/3 and then times the logarithm of 10. No, you are not putting in brackets. I don't.
Yeah, that's why I just erase it.
Sir, no, it look like him.
Yeah, no one is Ellen. And we don't write Ellen like this. That's Lane. We don't write Ellen
And
like that.
then
It's
you
just one
have
stroke.
the 10 raised to 3x plus c.
Yeah. All right. So yes, Alex, there's nothing too fancy about those. All right. So that's it. Now the fancy one comes now at 7:10. Is where we're going to be learning a little bit about some substitution. And I have to do this because I really need to get off the integration. As I said before, the good thing about it is that we are doing lots of integration. So when we're calculating the area under the curve, it is going to be even more seamless for you. We've done that already. So the just a few things that are left for me to look at. Maybe like a double integration. Yeah, double integration. Definite and indefinite, and then we can call it, whatever is left we can mop up, but these are the big ones. All right, so what I'm going to do now is to move into integration by substitution. All right, integration by substitution. I want you to be a little purposeful here in terms of paying attention. This is where it becomes a little tricky. You have to do some stuff and be very mindful of what it is that you're doing, or else you can get into trouble. I'm going to be teaching this by doing a question or doing several questions. Some topics have rules that I can give you the rules, and we can use the rules and play around with them like we just did a while ago. Others are a little bit more intricate. So I'm going to ask you to evaluate 10 x times 2x minus 1 to the 4 dx. And sometimes you see them say, so you're asked to evaluate upper limit 1, lower limit 0, x times 2x minus 1 to the 4th power. And they give you a hint. So once I give you the hint, that hint means that you have to use the substitution method. That hint is telling us that we have to use the substitution method. All right? Now, They're asking us to use u to be equal to 2x minus 1. They're asking us to use u to be 2x minus 1. Watch me. This 1 and this 0 is representing which variable?
The
X and Y.
limit.
Sir,
Hmm?
X, sir. X.
Oh,
X. Yeah, duh. Yeah, see, we're differentiating, we're integrating with respect to x. So it is representing x. Yeah, man, you're right. X.
oh, so that the X tells what
Tells us
variable.
what we're in. Yeah.
Okay. So if
Mm-hmm.
it was,
So now, mm-hmm.
if it was,
R,
it was dy
R or Q or P. No,
r.
if it was dr by right, what it means that the variable would be r. Whatever you see there in dr, it means that the variable is in r. The variable is r. dp, the variable is in p.
Okay, so
Sir, not to cut you, is that a elongated N with a flash to it?
Which
Or
one?
the hint? What is
Greek
that?
cube
Is that
is
a
a Greek
2
cube.
attached to the N? I'm confused.
come
What is
on.
that
Oh,
symbol?
It's a Greek cube, Siobhan.
Was a Greek U or Y?
Greek
Is that what his name? Or is that for the Y?
oh my gosh. On a can get Sarah a break.
Sir, use the next letter, I beg you.
You know, I'm convinced. I've lost the battle. I've lost the battle. You notice I'm not even going to take on tonight because last night my pre-calculus students robbed me out and tell me something I can't write. So no, I know I'm going to go to penmanship classes. I am going to do it,
Sir, right back
and
where did Avanta Coffee, you know?
because Jay, I bet you your chicken, the KFC where you eating now, going to taste better. All
No, the
because of what you
pasta
just said.
tastes nice, sir.
Oh my goodness. Say God no. That you eat?
Yes, sir.
Oh my goodness.
Oxtail, may I
None
eat
for you, sir.
KFC a little bit of food.
Mm-mm. Is that oxtail pasta or is just oh Lord? I mean I love the
Chicken
sound of that.
Alfredo.
Sir, I
Chicken
think you have
Alfredo.
to concentrate on the maths, now, sir.
Right.
Oh, that's a point I can't. Because he's talking about
A
chicken
big back
Alfredo.
conversation, sir.
Sir, she ain't gonna give you any. So just take your mind off
Alex,
it and let's
no, but
proceed.
Alex,
No,
no, Alex, no,
everybody but
no, tell
big
me.
man.
Oh,
Yeah, none for him.
Everybody want
No.
food. Focus on
just make just make sure, say,
And
not
it
this
tastes
year,
good,
but
sir.
next
So
year. Jesus, no, just make sure, say, next year. When I sit down in that graduation ceremony, me see the one and I walk past the stage because guess what? Me gonna get a tray of egg and
what do
me
I
see me,
with?
see,
A
see
duck me a
ya.
duck.
No man, just make sure you graduated. No, I wouldn't do that. But just make sure you graduated, no. Because for all the trouble and just make sure the valedictorian come from this class. Right? So
Sir,
just
aren't
make
we
sure say,
graduating in 2027? We're in third year.
yeah, no. So when I say next year, it's not next calendar year, but next school year.
Yeah.
Oh,
Yeah. So just make sure it's not all graduate here at the same time. I don't want nobody to go take no leave of absence or fail nothing off because we want the whole one to graduate at the same time.
No, sir, I
And we
wanna
want
move, sir. It ain't enough failure.
same way so. Same way so. All right, let's go. Let's go everybody and JJ with our Alfredo pasta. Let's go.
None for you, sir.
Here's your fight over the food. All right. So what's very
Sir,
important? Yes, please, my love.
can you what that hint that you put there? It was not you. Can you
It
write the
was
correct thing?
no, it was you actually.
It was
Yes,
wow. I'm a day I'll pick up for you. So please.
it was you.
Oh my God.
It was you. It was you. Oh my Lord. I'm gonna. I'm blaming it on the pen. Okay, so hint U. The letter U, as in under your umbrella, is 2x minus 1. And so the variable that we're in with the question is x. And then what is given to us now is going to be u. So what I'm going to do with this u is to find du dx. I'm going to find du by dx. What is du by dx, class? Equal to.
Sir,
So that would
4x.
be 2. That would be just 2.
Good job. It's going to be 2, and it's going to be 2 over 1.
Oh my gosh.
Right. Du by dx is 2. I'm
Oh
differentiating
my
u
gosh.
with respect to x. Yeah, man, the Lord forgives you. I'm going to differentiate u with respect to x. Watch what I'm doing now. When I have two fractions separated by an equal sign, what do?
You inverse one with
No,
fraction.
man, say cross multiply.
Oh, yeah.
A cross multiply. So if we have 2 dx is equals to du. And therefore, I want the value of dx. I'm going to divide both sides by 2. So dx is going to be equals to du over 2. Right? That is going to be used to substitute for that dx. Remember, I am making u the new variable. I am making u the new variable. So I've just gotten a substitution for my dx. See, my dx, that dx is going to be substituted. I'm going to substitute that dx for du over 2. You so see come together nicely, right? Now, all of this is going to be u because u is 2x minus 1. I need a substitution for this x. I need a substitution for that x. I need a substitution for that x.
So it's going to use the equation for you says to kind of find x.
Very good. So u is equals to 2x minus 1. So u plus 1 is equals to 2x. And divide both sides by 2.
Yeah. Let's see.
So x is going to be equals to u plus 1 over 2. I kind of started a difficult question, but maybe it's a good thing. Maybe it's a good thing. Maybe it's a good thing. Hold on for me, guys. It's a cut for me. I don't want to mess up my whiteboard, so let me just get it on the other device. Hold on a minute. Honestly, I really had Alex down as one of my G, but Alex licked it with Maya, and
What we do now? What have I done?
Sir, just call name.
Yeah, for that.
um,
Sir, a
yes, please.
question. After we differentiated du, which would be equal to 2,
Mm-hmm.
I'm not seeing where one, why would you put it as a fraction? And next thing, I'm not seeing where you get 2 dx over 2.
All
I'm
right,
not
so
seeing that second line.
no problem. All right. So when I differentiated du, when I differentiate that, I'm gonna get 2. Du by dx is equal to 2. Now,
Yeah.
all I'm doing is just putting it over 1 because I'm trying to find a substitution for dx. I'm trying to find a substitution for dx. So when I put it over 1, I'm going to have 2 fractions now, separated by an equal sign, so I'm going to cross multiply. I have 2 fractions, separated by an equal sign, I'm going to cross multiply. And when I cross multiply now, I'm going to get du times 1 is du, and 2 times dx is
Mm-hmm.
2dx. And because I want something for dx, I'm going to divide both sides by 2. So dx is going to be equals to, dx is going to be equal to du over 2. So that gives me a substitution for dx.
Okay.
Mhm. And then now I know that 2x minus 1 is going to be u from up here. So,
Mm-hmm.
but what is giving me a little challenge now is for me to put this x here. I mean, I made up the question, but really and truly, um, it can work, and I'm going to work it. Um, what would have been nicer for the first question for you, if I were to be honest, was just to, and I think I'm going to change it and then come back to this question a little later on. I'm going to change it because it is, for our first question, I don't want to shock you. I don't want to disappoint Alex to say, and Nigel to say, boy, sorry, the big one is. I'm going to come back to this one. I'm going to come back to that one. But I don't want to shock you for the first one because this one is going to be a little long. So I want to show you what it is, really and truly. Hold on. All right. So I see you, JJ. All right. So I'm going to give you. So I just erase the X because, as I said before, it's going to be a long one. I will come back to that X one sometime later and show you. And I will tell you when it is that I'm doing it so we can even compare the length of the workout. So we know what, so we have that substitution. So look at what I'm going to do now. Look at what I'm going to do. I'm going to say now, oh, you remember the one as the upper limit is also in X, but I don't want X. I don't want a value for X. I want a value for U. I want a value for U. So what I'm going to do is to say U. So when X is equals to 1, U is going to be equals to 2 times 1 minus 1. And 2 times 1 is 2. 2 minus 1 is going to be equals to 1. Uh-oh. Let's look at that. When I substitute the value of 1 into the function, I'm still getting one of the limits to be 1. It may not be the upper limit. It may not be the upper limit. So let us check when x equals 0 now. When x is equal to 0, I'm going to have u is equals to 2 times 0 minus 1, which is equals to minus 1. So what is now happening to us is that our upper limit remains as 1, but our lower limit is no longer 0, but it's now negative 1. Can you see that?
Yes, sir.
Yeah, man. It's very important. It's kind of the first question I can think of for this long while I've made up, and the upper limit is the same thing as the one that we calculated, right? So you remember you have to change over your limits. You have to change over your limits. You have to change over your limits. Very important. All right. So now that I have all my all areas to substitute, look at what I'm gonna have. Look at what I'm gonna have. I'm gonna have my integration sign. My upper limit is 1. My lower limit is negative 1. And then 2x minus 4 is u. So it's going to be u to the 4th. Dx is going to be du over 2. Can you agree with that?
Yes,
Look at
sir.
what I just wrote and tell me if you agree with all the terms that I've just written.
Yeah. Wait. Oh, yeah.
Sir, why 4?
Say it again.
Why 4, sir?
Because the question says 2x minus 1 raised to the 4th power.
And u is equal to 2x minus 1.
And u is equal to 2x minus 1, right?
Oh, okay.
Yes, the thing is, let me tell you.
Okay, so far?
Yes, sir.
All right, good. Now, when I'm integrating, you know what? Let me write this nice. So I'm going to have upper limit 1, lower limit negative 1, a half u to the 4th. Now, look at what is going to happen. Look at what is going to happen. The half is a constant. It's similar to the question that I started off with, where I just factored out the 42. The half is a constant, and I'm going to factor out my half. The half is a constant, and I'm going to factor out my half.
Yes, sir.
And then I'm going to work the rest of it. So watch me. So I'm factoring out the half. So now it's going to be 1 negative 1 u to the 4th du. When we integrate in, we add 1 to the power. Watch what I'm doing. U to the 5th over 5. Hold on. 1 negative 1. All right. So we're adding 1 to the power. we're dividing by the new power. Always remember, we're adding 1 to the power, and then we're dividing by the new power. So look at what is going to happen here. I'm going to have I'm going to have a half. Remember, it's the upper limit minus the lower limit. The upper limit minus the lower limit. So it's going to be 1 to the 5th over 5. That's like 15. 1 to the 5th over 5 minus negative 1 to the 5th over 5. Which is a half times 1/5. Uh-oh. 1/5 minus a negative 1/5. That's going to give me a half times 2/5. That cancels that. Is equals to 1/5 unit squared. Let us have a conversation about that. That's the end of the question. Let us have a conversation about that. So you're given a question. So you see how long this can you just picture why it is that I had changed the x from there, so you can see what is happening right there now? Why I alter the question? It's long. A question like this carries nothing less than 10 marks. Real talk. And it is highly dependent on the function. Because you see, if I had that x right there, so as I did before, that could have been an easy 50 marker. Because there are several things that you'd have had to do with that x. Like we saw we did, we put in the x and we transpose it and we ended up getting a fraction of for that. Don't remember what the fraction is, but we end up getting out some serious fraction for that. So we'd have had 2 sets of fractions. Well, we could have combined the 2 fractions and work out, but it would have been a little bit more. So what we do, when you're given the function, whatever to substitute, you have to use that. So we had to use our u equals 2x minus 1. We had to use our u equals 2x minus 1. Now, we need to make a substitute. All of this is in x. Every single thing right there is in x. So if we're making a substitution for u, one of the first things we need to do is to change that. So what we're going to be doing is to differentiating the u to get du by dx. So du by dx It's going to be simply 2. 2.
Sir.
Go ahead. Okay.
So you say if we're going to use u in place of, substitute u for the 2x minus 1, we'll also have to differentiate u to get, for us to get dx.
Got you.
Mm.
All right, now. One of the gentlemen in the class asked, "Sir, why is it that we put the 2 over 1? Because I wanted that transposition. I want to make dx the subject of the formula because I want to do a substitution for dx. So I'm putting the 2 over 1, and I know when I have 2 fractions separated by an equal sign, I cross multiply. So what is going to happen is this 2 is going to multiply by dx to give me 2 dx, and this one times du is going to give me du. But remember, the aim is to find dx. So I'm going to divide both sides by 2 so that I can have du over 2. So that I can have du over 2. All right? Now, that's what my dx is. So I now have a substitution for dx. I was given a substitution for this. I now need to be evaluating substitutions for 1 and 0. In order for me to do that, I'm going to go back to my original function and substitute 1. So this is 2 times 1 is 2, and 2 minus 1 is 1. I can't say that because this was my upper limit, this is going to be my upper limit. Sometimes when you work it out, students, your upper limit now becomes your lower limit, and your lower limit becomes your upper limit. Just remember, the bigger one will be your upper limit.
Yeah.
Right. Yeah, just remember that. Okay, now. Similarly, substituting the lower limit, 2 times 0 is 0. 0 minus 1 is minus 1. So I'm going to have minus 1. And that's my lower limit. And that's my lower limit. Then I'm going to set up my upper limit, my lower limit, x to the 4th or y to the 4th, because the question says 2x minus 1 raised to the 4th power, but 2x minus 1 is u. So it now becomes u to the 4th. And remember, we have to make the substitution for dx, and dx is going to be du over 2. So guess what? To set up your integration like this, you're going about 4 or 5 marks already, just to set up your integration. So, really go. Now, when I fix it up, I have this to contend with. So what I'm going to do is factor out my half. So constant. I can factor it out. It's not going to change anything. I promise you. You saw me do that with the differential earlier. It's not going to do anything with the integral as well. I can factor it out. I'm allowed to do that. So I'm factoring out the half, and then I have something easier now to integrate.
Sure, sir.
Integrating.
Just before we move
Go
on.
ahead, sir.
All right, so I'm seeing where when you get the substitution, which is integration, the upper limit is 1, the lower limit is negative 1.
Start again. Start
So,
again.
you hear
You
me?
broke up. Start again.
All right.
Hearing you now.
So I'm seeing where, right,
Mm-hmm.
after you find your x, after you said x equal 1 and x equal 0, and
Mm-hmm.
you then get the substituted version, which would be upper limit 1, lower limit -1, u raised to the power of 4 du over 2, which is essentially x, or sorry, dx, right?
Mm-hmm.
No, you're saying here, um, when you're doing the integration, which is always 1 over the differentiation of the function, which would be 2, right?
Mm-hmm.
I see we write back the u raised to the 4, which is the initial function, but I'm not seeing where the 2 gone. The du over 2 gone. Is why isn't that the same? Or why what happened to
Okay.
du over 2? Why is it just
So
du?
du over 2 is the same thing as a half du. Du over 2 is the same thing as a half du. You follow me?
Okay, okay.
Sir,
So,
is
so,
it
so
the same? I was gonna ask if it's the same principle for the uh when you call multiply.
you know what?
Never mind.
So du over 2 is the same thing as a half du. And you have seen me do that several times. I'm sure I did it earlier on in this question.
Sir,
So, yes, mommy?
yeah, so that is this what I was trying to see. Think. But no, it would have been the same. All right.
Yeah, man. Okay. You see, like all this now? This this answer, you may be looking for that answer on um on an exam paper. I'm not seeing it right written in that form. However, you may see it as e to the 2x over 2 plus c. The same thing. Because remember, this is over 1. Anything is written over 1. And you multiply these two to get that. This one is the same thing as having, I could write this as e to the x squared plus 5x plus 2 over 2x plus 5 plus c. I don't write it like that because I want you to see. I want you to see what it is. It is 1 over the differential times the exponential. It is easier to see like that. But if you're going to the exam and instead of combine it like that, are the same thing. Are the same thing. Trust me. All right. So with that said, Papa, good question. With that said, let us continue revising or reviewing our steps. So now we factored out the 2 and we got it as a half, and then we say, not the half can go to the other, so we can not change nothing. Hello, guys. Hear me?
Yes, sir. Hearing you.
Yes, sir.
Hello.
Sir, and I hear you.
Yeah, I don't know why I got bumped up and said, don't like doing this, because guess what will happen now?
You lose
And the
the white.
whiteboard not gonna come up.
You lose the whiteboard now, sir.
Is that good to let her finish working the question I was just trying to go through? Um, when I go to existing whiteboards, I can't even find the whiteboard. Okay, hold on. Ah, nice to meet you, mate. Mm. Hey, you, come on. Okay, right. So I am back at a point now where it's talking to you about now the integration of u to the fourth. I add 1 to the power divided by the new power. So it becomes u to the fifth over 5 right here. Then I'm applying my limit.
Sir, you
What
forget
then?
the permission.
Say it again, one more time.
Sir, the permission.
Oh, yeah. That's true. That's true. Thanks, man. And then what I'm going to be doing here is applying my limits. How do I apply my limits? Upper limit minus a lower limit. Upper limit minus a lower limit. So it's going to be 1 to the fifth power over 5. And then this is going to be minus -1 to the fifth power over 5. Always remember that when you're multiplying, always remember that when you're raising a negative power for an odd number, the result is negative. A negative number to an odd power, the result is negative. So that becomes -1/5, but that -1/5 is being multiplied by a -1, so it becomes a +1/5. And 1/5 plus 1/5 is 2/5, and 2/5 times a half is 1/5 unit squared. And that's it. That's it. And that's it. Any questions? Mm? what I'll do is I'm afraid to make up my questions on this because my question then give you like this last one here, then give you one heap of work. If you can find one in say 2 minutes on a past paper, together we can work it in another couple minutes up to the end of the class. Anybody want to check for me, please? I can make up on it, but I don't think anyone might want to make up. Alex, I got talk off in place and Niger too. So if you can find one in a multiple in a past paper, it take 2 minutes and look for one and come back to me. I'm right here.
All right.
No luck?
So I sent one in the chat.
I didn't see it.
Oh, I found.
Right,
a
Keith.
few.
No, you're here, right?
No, that one though is what I want. We can work that some other time, but what the one that I want on the past paper, it would say to you, yeah, so this is an integration question, but
So I sent another one.
it's not a substitution. The substitution I'm going to give you a hint. Use
Oh, yeah. I don't see any in these parts.
right. So these are regular integration questions. Yeah. You can work these for me. You can work these for me as practice, all of you. Moya, do me a favor. I'm giving you permission, Moya, to copy those two pieces of stuff so it can be included in the discussion board. Those are practice questions that I want you to have. But the ones that I want you to look at now are the ones that says hint, use this as that. Use this as a substitution.
Sir, you want us to use what again?
No, I'm just asking if you can copy those two pieces that you put in the chat a while ago to the whiteboard so that when the whiteboard is downloaded by the class, they can have those questions to do. But what I'll do is try and find, since we're at the end of the session now, I'll try and find, or you can help me try and find some questions so we can apply the substitution. After the substitution, I'm going to press pause and find some other area. I think we have done. I think we have done pretty well. Yeah. Let me know when you get through Maya. Okay, good. That's one.
Oh, sir, you don't want that one.
Mm-hmm.
But when I put it, it keeps coming off. So I guess you don't want us to do that
No,
one. The first one.
no, it's not me. Put it,
Hmm.
man. Put it, man. Put it back. Put it back. Put it back, man. It's not me. I didn't delete anything.
I guess we don't want it then.
All right. So what is going to happen here? Because I just um made up a question, and it is giving me some very big values, and I want to give you one of the questions like what is on the paper. I don't want to shock you with these questions. I believe that is these are supposed to be getting. Um, you did well for tonight, as per usual. Um, you make teaching a little easy for me. Um, we are wrapping up. Really, we have completed the mere fact that I did stationary points up front to facilitate those business calculus students. Well, trust me, if you were, you wouldn't have time to type that. um, it made life a little bit easier. Maybe something to think about. Putting one of the big boys them up top so we can get through some of those things from earlier on. And then I did look at some integration area under the curve with you. So there are some smaller areas. One such area is I'm going to go back to limits. I'm going to go back to limits because there is something that is called um, L'Hopital's rule to evaluate limits using L'Hopital's rule. Now, L'Hopital's rule is using differentiation to evaluate the limits. So I'm going to go back to limits just briefly to teach you L'Hopital's rule. You know how to do limits already. You know how to differentiate already. I just going to bring the two of them together, and then you see it nicely. And then I'm going to do some double integrations with you. And I think that should take us into the end of the session. So come Tuesday, hopefully, we can finish. And then on
Wednesday.
On Wednesday, sorry. Yes, thank you, sir. Just say that to see if you're still awake. So we're going to come on Wednesday, see if we finish. And then on Friday, we're going to have a class party. So how we're going to do the class party? Everybody can carry something, either popcorn or I don't want to call the name of a drink,
Where will
but
this be?
you can carry something come to class. And we're going to turn our cameras on and we're going to be learning in style. No, seriously, no, man, true, something, man. We're going to carry those who like popcorn, we're going to carry them popcorn. If you want your burger, hey, JJ, it's like what you can carry shrimp pasta, right?
So your chest higher.
And then you just come to class and we're going to have our cameras on. Yeah, man, and we're going to eat, make everybody silly. And we're going to do it things and we're going to learn same way. And it's going to be a lighter class because by then, you know, it's pretty much wrapping up time. It's pretty much wrapping up time. And we should be fine. Send you off and then we plan on some dates, where we're going to be meeting. It won't be every day, but one or two times. I just want to meet with you then, so that I know that you guys are putting in some work. I don't want me not to get back in January and rusty and go fail the exam. The business calculus students did it. 13 students sat the exam, 12 students passed. All right. I really wanted 13 of them to pass. And I don't even know how many students I have in this class now because some people missing for weeks and then turn up. I don't even know. But this is it. Big up on yourself. Have a good one.
Bye, sir.
Mm-hmm.
Sir. Oh my God. Him gone? Sir, not even responding to Kilo. Let me see if I have it. There.
I whiteboard, don't Maya.
Hmm?
Whiteboard, then.
I well. Yeah. Yeah, this is what I have. Was there anything else? This was the last one, right? Nothing more.